Well, welcome everyone. I think we'll start our this afternoon's webinar. Thank you all very much for attending the webinar this afternoon, which is titled Empowering Civil Engineering and Construction, the Power of Collaboration Technologies. This is brought to you by the South African Institution of Civil Engineering, and it's the IT division that is actually presenting this to you. Before we begin, I'd like to take you through a quick overview of the SAICE IT division. The focus of the division is to add value to educating our industry on new technologies, new developments, for example, Fourth Industrial Revolution, artificial intelligence, BIM, cloud collaboration, Internet of Things, etc., both from a hardware, software, and human perspective, and to reimagine our workflows through 2023 and beyond. So in line with our objectives, the division seeks to expose new technologies that may become useful to civil engineering profession, particularly as the traditional boundaries between engineering disciplines are becoming increasingly fluid. We aim to serve our members by providing relevant content timelessly, always taking into account the needs of our profession, and also to attract more professionals into the industry, particularly by encouraging the young and the older professionals to become aware of new technologies, whilst always maintaining regard to the social, environmental, and economic impact. So before we actually kick off with the webinar, a couple of housekeeping points. If you've got any questions as you're going along through the webinar, do type them into the Q&A box. Okay, not the chat, the Q&A. And then at the end, we will get to those questions and we'll run through them and see if we can then get them answered for you. Extra CPD points have been applied for this webinar. So I'd now like to introduce our speaker for this webinar. Marius Bierman is a virtual design and construction manager, currently with Murray & Dixon Construction. Marius is a civil engineer. He has a BEng and MEng from the University of Johannesburg. He is experienced in construction management, business management, BIM, and has exposure to civil design. He's a passion for BIM and collaboration technologies. He's also experienced in 4D construction simulation and 3D construction illustrations. Marius is an associate member of SAICE, and thank you very much this afternoon for giving up your time, Marius. I'd just like to say it's actually quite nice because normally in our webinars we concentrate kind of more on the design side, so it's very nice to have you along this afternoon to give us more perspective from the construction side. So with that, I'd like to hand over to Marius. Over to you, Marius.
Hi, Peter. Thank you very much. And good afternoon, everyone. Thank you for the kind introduction. So I don't really have to go through the whole process. So you saved me about additional 5 minutes. So let's get cracking. Okay, as mentioned by Peter, the topic of this webinar today is empowering civil engineering and construction, the power of collaboration technologies. And what we found is interesting with collaboration technologies, it pulls in all the different stakeholders, whether it's from design, construction, the client, the architects, what other industry stakeholders are involved. So it's extremely exciting for me to share this webinar with you. So let's get to it. Let's go to table of contents. So looking at our agenda for today, we will embark on a journey back into the understanding of our roots and the traditional methodologies that lay the foundation of our industry. We'll analyze the current landscape, diving deep into collaboration tools that have become indispensable today. A detailed exploration awaits as we'll understand the nuances of each significant technology that makes waves. And of course, we will gaze into the future, speculate and understand what lies ahead for civil engineering and construction in this era of rapid technological advancements. Okay, so introduction. The story of civil engineering and construction is one of continuous evolution. We've progressed from rudimentary tools and manual labor to leveraging some of the most advanced technologies available today. So with this webinar, it's not just about listing out technologies and tools, but it's also to understand how these technologies has redefined collaboration, enhanced efficiency, and brought about revolutions in our field. It's about the incredible journey from traditional brick and mortar methods to digitized, interconnected, and collaborative environments. All right, so let's look at the historic perspective. Don't worry, we will not start from the beginning of time with a big bang, but in the world of civil engineering and construction, we know it today stands on the shoulders of centuries of development, innovation, and hard-learned lessons. And I'm sure we all can attest to that. This historical perspective aims to offer a panoramic view of our journey from the earliest known civil engineering feats to the dawn of the digital era. As we delve into the landscape of civil engineering and construction over the last century, it becomes clear that development within these decades has been pivotal, setting the stage for modern technology marvels as we have at our disposal. So in the early 20th century is our foundations of modernization. So we're not going to go into too much detail in each of these areas, but it's worth noting that throughout the 19th century, or the 20th century, we marked a shift from brick and mortar structure into reinforced concrete and structural steels. And this development in materials gave us the opportunity to construct bigger and greater structures. We also, the advent of mechanization, the widespread adoption of machinery such as cranes, dozers, excavators, whatever else is out there, that changes the face of construction. The pace increases and not only accelerates that, but also enables us to embark on larger, more complicated projects. Around about the mid-20th century, technological integration and globalization played a role, so which is the birth of computer-aided design. By 1960s to 1970s, the first instance of CAD system began to emerge. Now we're sitting with far more complicated tools at our disposal. While initially rudimentary, these systems laid the groundwork for sophisticated design and simulation tools that professionals rely on today. So globalization, yes, latter half of the century saw increased collaboration and exchange of architectural engineering ideas globally. International standards started taking shape, fostering consistency and bringing innovation at a global scale. So there was also an infrastructure boom post the World Wars. We're not going to delve into that, but the whole concept was companies embarked on ambitious infrastructure projects, developing bridges, dams at an unprecedented rate prior to that. So transitioning to the 21st century, the digital revolution, emergence of building information modeling has revolutionized the industry. As we approach the new millennium, the industry began to embrace BIM. This collaborative approach to design and construction enabled professionals to create and manage information about construction projects in all-encompassing digital format. The integration and advanced tools of the late 20th century and the transition in the 21st saw an increase in the integration of advanced tools, all the way from laser scanning to advanced prefabrication methods, all contributing to increasing efficiency and precision. So let's look at the landscape where we find ourselves now. So within the architectural engineering and construction industry, referred to as the AEC, is a key contributor to the social economic development of any country. With that being a very important aspect of our industry, we also need to keep in mind that we are unfortunately one of the worst performing industries when we're considering productivity and innovation. The industry is also considered the least digitized. And a very interesting topic is the average industry profit margin is about 2.2%. It sheds a little bit of light why there's a reluctance to invest in digital tools. It's also further described as an industry of a once-off endeavors, project-based, inflexible nature, prevailing high risk, operating in silos, which we will discuss a little bit later because that's one of the key areas when we talk about collaboration. And of course, we have, unfortunately, sometimes a fragmented nature or culture. So in our current landscape, what we face is silos. Despite the leap and bounds made in civil engineering and construction sector, one pressing issue has proven tenacious. The persistence of siloed operations and limited interdepartment or interorganizational collaboration. The reality of siloed operations is, well, in context of our industry, working in silos refers to scenarios where different departments, teams, organizations manage the operations independently, with minimal communication, knowledge sharing, or collaboration. So some of the symptoms that we found as common manifestation of silo operations include duplicated efforts, inconsistent documentation, misaligned goals, and delay due miscommunication or awaiting approvals. So project fragmentation, I mean, that's a kind of self-explanatory, as one major symptom is fragmented project stages. From design to execution to handover, the lack of synchronization often means that each phase functions almost as its own entity, rather as an interconnected part of a singular project. So if you look at some of the root causes of working in silos is traditional hierarchies. So a lot of the times information flow top down, which create an environment not conducive to lateral communication. The industry is also found to have a protective mindset that they don't always want to share all the information because holding on to their information gives them an advantage or protects their interests. Technological barriers has also played a role. While the tools are available, not every organization or team has adopted them. There's a whole host of reasons for that. We're not going to spend too much time on that, but we do know that technology barriers, or rather the use of it, is a problem. All right, so what are the implications for projects in the industry? So efficiency loss, increased error margins, stifled innovations, and delayed deliverables. That is not a good thing for a project. So now we've set the scene for where we come from. We understand that there are tools available. We also know that we operate in the industry in silos and collaboration is a problem. But let's have a look at some of the tools and technologies that is available to us as an industry and should really consider investigating and utilizing these tools. So just from the top, building information modeling, reality capture technologies, construction simulation, virtual reality and augmented reality tools, digital twins, and artificial intelligence. So let's first have a look at building information modeling. So there are so many different terms to describe what is BIM, but for this presentation, we will rely on the ISO definition, where it states that the use of a shared digital representation of a built object. I need to stress this, that it's anything that we build, bridges, houses, roads, water treatment plants, doesn't really matter. To facilitate design, construction, and operation processes, to form a reliable basis for decisions. So BIM goes beyond mere 3D designs, is a digital representation of the physical and fundamental characteristics of a facility, evolving from basic modeling to encompassing aspects like time, cost, and sustainability. I might just add that in terms of building information modeling, the term building is slightly misleading, and the industry is moving more towards adopting a term called digital project delivery, because building information modeling originated in the building industry, focusing on the building aspects. So when we say BIM, rather consider it being called digital project delivery. Yes, the role in enhancing collaboration with BIM, architects, engineer, contractors, and the clients can collaboratively interact with the model, making real-time adjustments and decisions, thus breaking down these traditional silos that we've seen in project delivery. It allows us for real-time design changes and visualization. So BIM-enabled platforms allows instant updates when one team adjusts a section on the model, the other sees the changes instantly, enables quick decision-making and cohesive designs. Also, it allows integration of other tools. BIM doesn't just stand alone. It can be integrated with other tools for tasks like project management, material tracking, and more, making central hub for construction projects. I have put in a note at the top right corner for those that have heard about BIM and BIM mandates. South Africa currently doesn't have a BIM mandate, but I need to bring it to your attention that the CIDB, so it's the Construction Industry Development Board, is in the process of compiling a BIM mandate for the industry. When that's going to be published, we are not too sure just yet, but that is on the cards. Yeah, so looking at BIM quickly, it's a process including people, process, and technologies. People is the project stakeholders. Process, we've mentioned ISO 19650 as the process for the industry, and then of course all the technologies involved with it. So you said, what is BIM? Let's say what is BIM, what it's not. BIM is not software, and the software resellers will be very unhappy with me saying this, but they punt software as BIM software. But to understand it correctly, BIM is not software, it's not hardware. It is a way in which we work with the digital information in a collaboration with project stakeholders. So I'm not going to spend too much more on BIM and the concept of BIM. If you'd like to know a bit more, there is a community called the BIM community, and they also have some information on there if you're interested. Yeah, one of the profound aspects of BIM is the use of Common Data Environment, or CDE. So Common Data Environment is a centralized digital platform or repository used in the building information modeling process. So this allows us to store, manage, and distribute documentation, graphical model data, and non-graphical data associated with the built asset. So the CDE ensures that project stakeholders have access to a single, reliable, and up-to-date source of information. You will notice that there is a term in the industry where they call it a single source of truth. So it promotes transparency, reduces errors, and fosters a collaboration process throughout the complete project lifecycle. So the concept of CDE, emphasized and standardized in ISO 19650, the national standard that sets out the processes for managing information over the built asset's lifespan. The standard delineates the process and procedures for using a CDE to manage and share information efficiently, ensuring that consistent, clarity, and compliant across global construction projects. Okay, again, I'm not a software vendor, so I'm not trying to sell you software. I just want to showcase some of the tools that's available as Common Data Environment. Most engineers are familiar with Autodesk. They've got a package called BIM 360 and currently known as Autodesk Construction Cloud. There are, however, a few alternatives, which is also used in the industry, Procore, Bentley ProjectWise. So a lot of the, and we'll get to it at the end of the webinar, some of the issues that we face, that each of these software vendors tries to sell the product, but doesn't necessarily understand the interface between the different construction role players. Meaning that generally in a contract or a project, you've got multiple stakeholders. You'll notice on the left, this is a traditional communication process. It's not really structured, and you can imagine that information gets lost or responses get delayed. The one doesn't know what the other one is communicating, working off their own plans. Now, Common Data Environment seeks to alleviate that problem, where all project stakeholders interact with the common data environment. And really, it doesn't matter which application you use, the principle remains the same. Live data is available to all project stakeholders. Okay, so now we know about building information modeling, common data environment. We mentioned that there's certain tools that you can add onto the actual information. So we look at reality capture technologies. So in recent years, reality capture technologies, including drones, 3D point cloud scanners, and 360-degree cameras, as emerge as transformative tools in the civil engineering construction sector. These technologies capture accurate, detailed, and comprehensive data from real world, allowing professionals to interact, analyze, and collaborate more effectively. So let's delve a little bit deeper into the technologies and uncover their pivotal role in advancing collaboration. So drones, again, there's so many different terminologies: drones, UAVs, RPAS. So let's just refer to them as drones. So as we all know, high resolution aerial surveys, that's a standard practice with drones. So it's equipped with sophisticated cameras and can quickly survey vast construction sites. It could be construction sites, or it could be during the feasibility stage or the planning stages, to either inspect brownfields or greenfields projects. So it provides top-down imagery that can be overlaid with design plans for verification and adjustment. I must add to this that the technology has advanced to such an extent that you can do quantification of stockpiles, which is a quite handy tool. Real-time project management. So drones enable project managers and teams to monitor construction progress in real time, ensuring that everyone is on the same page regarding timelines and project potential challenges. One key aspect of drones is it allows us to access difficult areas or unsafe areas where we won't have to send some of our employees to go and work. Then moving over to the 3D point cloud scanning. So it creates an accurate digital representation. So the point cloud scanner captures millions of data points from a site, resulting in a 3D digital representation. I would not necessarily call it a digital twin because the digital twin has so much more detailed metadata involved to it. So we'll discuss that later on. This representation can then be used for design validation, progress tracking, or even historical documentation. So like creating as-builts. So integration with BIM-enabled software. So the data from the 3D scanner can directly be imported into some of the BIM-enabled software. It enables designers, engineers, contractors to work with real-world conditions. So the symbiotic relationship ensure that designs are practical, feasible, and aligned with on-site realities. But also a big advantage is if you create your 3D point cloud, you can overlay your design model and you can go and do repetitive scans to verify the progress, and you can pick up if there's any alignment issues. A very good example is we were installing reinforcing for columns. We did a scan, overlaid the model, and realized that some of the columns reinforcing sits 50 to 60 mils outside of where it should be. We would have only picked that up once we've placed the concrete and we realized there's a problem. But that allowed us to go back, repair, reinforce, or move the reinforcing to the right location, put it in the formwork, and we know it's in the right location. Also with the data that you capture, the data can be made available to various project teams. So you can collaborate with other stakeholders with the point cloud data, whether you're doing coordination, whether you're checking, verifying design versus as built. It just provides you accurate and updated information. All right, so we look at 360-degree cameras. So these cameras have been around for quite a while. It had its uses. But with 3D imagery, stakeholders can now physically present a site to the clients, to their fellow team workers, with their fellow stakeholders, and provide them an off-site access to the site. So a lot of projects you find, onboarding process is quite laborious. There's a lot of safety requirements, medicals, inductions, different kind of industry required training before you can access site. With the use of 360-degree cameras, you can bring the site to your clients, to other stakeholders that won't necessarily have access to site. So is that the only benefit of it? Not really. It has an amazing ability to document and for record keeping. So the camera captures comprehensive view of the site at various stages. As the value, such documentation can then be shared among collaborators for review, quality checks, or future references. It has also gained popularity for end of project snagging, to go and rectify defects. So it's a lot easier to identify locate and track and record defects. So integration with other technologies. So once you've captured your 360-degree information, you can then use virtual reality platforms. So you now have got a real-world site that you've captured with your 360-degree camera. You can now use virtual reality platforms to have an immersive experience to go through site. So stakeholders can walk through the site, discuss challenges, and brainstorm solutions in a virtual yet realistic environment. Okay, so collaborative advantages. So why do we even want to use some of these tools? So unified understanding. Reality capture technologies ensure that every team member, regardless of their physical location or role, has access to the same detailed and accurate data. This unified understanding is the bedrock of effective collaboration. It improves problem solving and decision making. So the real world data is at their fingertips. The team can collaboratively identify issues, brainstorm the solutions, and make informed decisions quickly. I mean, a lot of the project delays could be avoided if a decision can be made quickly. And a lot of the times, the information that's presented to make a decision is insufficient or is ambiguous. So if we can make informed decisions quickly, we'll be able to minimize delays and cost overruns. Stakeholders, one of our big aspects within the industry is we need to keep our clients and other stakeholders on top of progress on what's happening on site. So using these reality capture technologies, we can actually bring non-technical stakeholders into the fold and collaborate with them to indicate where are the issues, where are the backlogs, where are the challenges that we need to overcome. And this actually promotes trust and open communication. So in summary, reality capture technologies are not just tools for collecting data, they are bridges and connecting diverse teams, ensuring that everyone collaborates using the most accurate and up-to-date information. So as the technologies continue to advance, the role in fostering collaboration and streamlining project workflows in the civil engineering construction sector will only grow more significant. Yeah, so we've got the design, we've got the model, we've got reality capture data. So without the preceding information, construction simulations would not be possible. So the civil engineering and construction industry stand on the cusp of a digital revolution. And at the heart of this transformation, I would assume, is the construction simulations. By leveraging 3D models, data from reality capture devices, and advanced collaboration platforms, construction simulations are redefining the benchmark for precision, efficiency, and synergy in the industry. So let's have a look at the interplay between the different elements to understand how they foster unparalleled collaboration. So again, we mentioned 3D modeling. If we didn't have the 3D model, if we didn't have building information modeling or digital project delivery, as it's also called, it would not be possible. So 3D modeling tools allow for creation of detailed and accurate design representations of the proposed infrastructure. So these digital representations serves as a virtual prototype, aiding in design validation, feasibility studies, pre-construction analysis, and also during construction. So there's multiple scenarios that you can run, and I will show you an example just now. So one benefit as well is dynamic adjustments. So as projects evolve, 3D models can be updated in real time, allowing for adjustments based on changing requirements or unforeseen site conditions. So this fluidity ensures that all stakeholders remain aligned and informed. So here's one of the big gripes, if everybody has worked on a construction site or involved with a construction project, is mid-construction, a design change come into play. That has a massive roll-on effect on the planned program of the work. A lot of the times, changes to design is not always really considered and its impact. And once you update a Gantt chart, which is also a valuable tool, you tend to find that there's misunderstanding about what the impact the design change has. Okay, so data from reality capture devices. So we can overlay real world conditions. A lot of the times on construction sites or projects, we do not necessarily consider all the existing infrastructure or issues on site. And I know a lot of times in contracts it's written that the contractor or subcontractor will make themselves aware of all the site conditions, but you cannot really interpret a photo and understand the full implications. By overlaying real world data, which we've captured either with the drone, the 360 camera, or the scanner, we can have a better understanding of real world conditions when we overlaid the design model and understand the implication. Next one is our progress tracking. So as construction progresses, of course, we need to keep an update, but updating a 4D simulation program based on the model elements gives us a better indication of where we are on the project. So we're not just relying on interpreting a Gantt chart, but we can see a physical element being built. So if a Gantt chart has a section where you said the roof is 100% constructed and complete, but the walls have not started, a lot of the times in Gantt charts it's difficult. It's also difficult to track exactly what's the correct sequence. Okay, so the collaborative hub. So the advanced platforms in 4D simulation. So it allows us to have unified access. So the construction site, the client, any other stakeholders got access to the simulation to see what is the plan and what is the actual compared to the physical design model. Modern platforms also allow team members to go into the model, raise flags, suggest changes, highlight potential changes. It also assists with versioning control. So given the dynamic nature of construction projects, is crucial to track the changes and maintain version histories. So collaboration platforms streamline this, ensuring that teams always work with the latest proven version of the model and also trace back to what's necessary. So benefits, of course, predictive analysis. You can run simulations. You run different what-if scenarios to find the best solution. Stakeholder engagement, again, if you can show visually to your stakeholders, they're more likely to be engaged. Also training onboarding. A lot of the times we find that when you go to a construction site, some of the client requirements ask for local labor to be involved. And most of the time, local labor does not have the site experience. So to explain to them the process and what they need to build, the 4D simulation becomes absolutely critical. So if you're interested to know a little bit more about the construction simulation, so there's a few tools you can investigate. Synchro 4D, Baxel, Navisworks. It used to be Navisworks Simulate, but now it's Navisworks Manage. I2 and Vico Control. So as an example about 4D simulation, so this is a real world project that we've linked the 3D model, which we've received from the design engineers, to our construction schedule. And we can go through multiple iterations and verify and make sure that the sequence makes sense. We know what is the correct phase. We can identify potential hazards. We can include cost into our simulation as well to do earned value calculations. We can build risk allowances within our project. We can go backwards and forwards, scrub through the program and re-plan the work. So if a certain area is delay, we can go back in and replan it and show visually what the implication is. Okay, so construction simulation enriches the 3D modeling and reality capture data. And housed within advanced collaborative platforms are the lighthouse guiding the industry towards a future to share visions and our unified efforts. As these technologies continue to evolve and become more integrated, the boundaries of what is achieved in civil engineering and construction will expand, setting new standards for excellence, efficiency, and what this industry really can do. Okay, let's move to the next. Why isn't it moving? Here we go. Okay, so the last few topics I'm not going to delve too deep into because each one of these areas have got its own nuances and ways that you implement it. So let's take it from the whole process. We've got the 3D model. We've got the common data environment that everybody has got access to. We've got the 4D simulation now, seeing your timelines. You have reality capture that you've done, whether it's drones or 3D scan. What you then can do is funnel all this information and have an immersive digital experience on the site. So the fusion of virtual reality, sorry, just missed something there. Give me a second. So immersive digital environment. So interactive 3D models. Virtual reality allows us to take the 3D model, all the interactive information, and you have a physical walkthrough. So this is a way to identify issues in design or construction or queries or issues that needs to be resolved. So with VR headsets, team members from across the globe, well, if you are working globally, because a lot of the consulting firms have global partners, can simultaneously inspect a virtual construction site. The shared experience, irrespective of geographic location, ensures a unified vision and understanding of the project details. Augmented reality is a different scenario. So augmented reality overlays digital data on a real world. Meaning, by overlaying digital designs onto a physical world through AR glasses or mobile devices, site engineers can instantly compare planned design with on-site progress, and discrepancies can be spotted and rectified on the spot, minimizing costing delays and rework. Again, AR, VR is an amazing tool to use for client engagement. So the AR allows clients to visualize the finished product on the actual site, even before construction starts. This can also be done visually inspecting the site during construction and after construction. So mixed reality is an emerging field. So it's a combination of both virtual reality and artificial augmented reality. It offers a more immersive collaborative experience, the potential application in construction from design brainstorming sessions to complex on-site integrations are vast and quite frankly, very exciting. So the realms of VR and AR are not just augmented or reality, but are revolutionizing the very fabric of collaboration in civil engineering construction. As the lines between physical and digital blur, teams are discovering newfound synergies, making collaborative efforts more intuitive, informed, and innovative. So if you embrace these technologies, it's no longer a futuristic vision. It's an immediate imperative for those aiming to refine the benchmark of excellence within the industry. So again, these tools are readily available. We need all the preceding information at our disposal and then utilizing the tools. So again, on the right-hand side, is just a couple of tools you can look at for VR glasses. I would suggest you have a look at Trimble XR10, which is quite amazing, specifically when you look at the construction industry. I think Trimble XR10 uses the HoloLens as the basis for their technology. Okay, so all this information boils down to digital twins. So digital twins is not just a 3D representation. It provides a unified project view. So by creating the virtual replica of a physical asset, process, or systems, digital twins have become instrumental in streamlining operations, enhancing productivity, and bolstering collaboration. So if we look into digital twins, it can have a profound influence on a collaborative endeavors. So a digital twin is essentially a dynamic and digital representation of a physical asset, system, or processes. It integrates real-time data. So this is through the connection of IoT devices or other sensors. It could include simulations, advanced analytics, but basically it mirrors the life cycle or performance of a physical counterpart. So while 3D models provide spatial representation, digital twins evolve continuously, mirroring real-world changes, conditions, and performance. They are living entities reflecting the ever-changing nature of construction projects. So it could be used in multiple aspects through the design planning, the construction, the maintenance. The main benefit that we see is for the maintenance and operation. Post-construction, digital twins transition from assisting in building to aiding in facility management. If you look at the cost of a facility, you have an upfront cost for design, which is a short duration and not a high cost. You have a construction phase that is a longer duration and a much higher cost. But then you have the operational period that is for a much longer duration, and potentially that's the biggest cost on any built assets lifecycle. So maintenance and operation, that is key. Again, we're not going to delve too much into the digital twins. Again, if you want to read up a little bit more about digital twins, there's a couple of software applications that you can look into. I would suggest you go and Google Twinzo. It's a very unique application. And I also understand that Autodesk has got a digital twin application in the workings. Yeah, now we get to artificial intelligence, the dreaded artificial intelligence, where everybody is worried that it's going to take our jobs. But in fact, artificial intelligence is human intelligence just in a very nice systemized process. Also, if people are concerned about losing their jobs, there's a saying that says, AI won't take your job. However, the person that learns how to work with AI will eventually take over your work. So artificial intelligence is a vast capability to process, analyze, and interpret data. It's heralded a new age in civil engineering construction industry. So the application spans from all the way from real-time data analysis, predictive analysis, automated reporting. You can assist with design iterations, resource allocations, safety protocols, can assist with drafting documentations, reviewing documentation. So end of the day, AI is a assistant to an engineer. It won't take the work away from the engineer because there is significant thought behind the design process, but AI tools will make our life easier. So the integration of artificial intelligence into the civil engineering construction domain is not just a step forward, it's basically a leap towards the future of unparalleled collaborative efficiency. By offering data-backed insights, automating mundane processes, and I'm sure we all have some of those, and fostering proactive decision-making. AI is setting the stage for collaborative endeavors that are more aligned, informed, and effective. So as the industry grapples with its increasing complexity, tight timelines, and rising demands for quality and sustainability, AI does emerge as an indispensable ally, propelling collaboration to new heights. So it's worthwhile investigating and utilizing the tools. Again, with the more known artificial intelligence tools out there, ChatGPT, Bing AI, Bard, and a few others, it's worthwhile investigating and see how that can assist you with automating mundane processes. So challenges and future outlook. Of course, technology is interesting. There's always challenges, unfortunately. So if we look at integration of multiple tools, the market is sometimes flooded with new software, digital solutions. Integrating these platforms seamlessly becomes a significant challenge because every company engineers their preferred tool, but integrating multiple tools sometimes become a problem where there's interoperability issues. So ensuring that tools communicate with each other effectively without loss of data or functionality is pivotal. So I think a lot of work has happened in the past, specifically with the file naming IFC. This made big strides towards interoperability. Training and upskilling of workforce. Normally, training and upskilling is a problem in its own right for normal operations. But with the rapid advancement of technology, demands an equal rapid upskilling of the workforce. So maintaining a team that is not only familiar with also maintaining a team that is not only familiar but also proficient in modern tools and modern requirements, continuous training and investment. So that is a key area to improve our workforce. Again, if we go back to building information modeling, we said it's a process of people, technology, and process, where people is one of the key elements. Data security concerns, of course. Digital information transformation comes with challenges of securing vast amounts of data. Again, who owns the data, who has access to it, who can share it. Economic fluctuations. So civil engineering and construction sectors are often the first to feel the ripple effect of economic downturns, affecting project funding, client commitments, and overall market stability. Sustainability pressures. So global emphasis on sustainability grows. The industry faces pressure to adopt eco-friendly practices, materials, and designs. A challenge given the holistic reliance on methods not always aligned with green principles. So these are some of the challenges facing the utilization of the tools. And one of the key takeaways from this in terms of challenges is for these challenges to be mitigated, some unfortunately is out of the control of the industry stakeholders, but for those that have control, should communicate their requirements. And this is straight through all the project stakeholders, from architect, engineer, client, contractor, subcontractor, supplier. Communicate their requirements in knowing what they want to use the data for, how they want to use it. I think that's quite pivotal. Okay, so not to be all doom and gloom, but let's have a look at the future outlook, see what this could mean for us as an industry. So as the civil engineering and construction sector transition towards a more interconnected and globalized future, the importance of collaboration becomes paramount. Envisioning the upcoming era, one can identify key trends and innovations where collaboration plays a pivotal role in unlocking new potential and driving transformation. So here's just a quick glimpse of what this future could look like. So integrated digital platforms. The construction project of the future will increasingly rely on unified digital platforms that facilitate real-time collaboration, tools that seamlessly integrate various stages of the project, from conception to execution and maintenance, will enable diverse teams from across different stakeholders to work in tandem. Decentralized decision-making. Again, this takes us away from a silo mentality. With the rise of cloud-based collaboration platforms and real-time data analytics, the decision-making process will likely become more disrupted. Teams on the ground will have access to the data and tools they need to make informed decisions without always waiting for top-down approval. Collaborative design and AI. So as building information modeling evolves, its collaborative nature will be enhanced with AI-driven insight. Multiple stakeholders, whether architects, engineers, clients, or contractors, can collaboratively interact with design with AI suggestion optimization based on each stakeholder's input. Globalized project teams. So advancements in communication technologies and collaboration platforms will empower organizations to form project team comprising of the best talents around the world. So this global collaboration will lead to richer ideas, diverse perspectives, and innovative solutions. Sharing learning and knowledge base. So the future will likely see the rise of industry-wide collaborative platforms where professionals share insights, learnings, and solutions. This shared knowledge base will accelerate problem solving and promote best practice, benefiting projects globally. One of the very key ones is stakeholder engagement. The next era of construction will involve not just professionals, but also end users and the community at large. Collaborative tools would enable early and continuous engagement with the public, ensuring that projects align better with societal needs and values. Sustainability through collaboration. So yeah, of course, sustainability, it's one of the key things that's on the cards. So tackling global challenges like sustainable requirement, collective effort, Collaborative platforms will facilitate the sharing of green technologies, eco-friendly construction methods, and sustainable design principles across borders. Real-time supply management, we're going to delve too deep into that. But it does assist us in collaborating with making sure that the supply chain provides materials and equipment in a timely fashion. So even though we've got challenges, there are some very unique future outlooks. And it really depends about an industry looking into where we come from, what are the tools that's available to us, how can we find ways to collaborate better? Because if we collaborate better, there's a higher likelihood of project success. And also breaking down the silos where we as an industry start breaking down those old sayings of we are the least digitized and we're not innovative. So that brings us to the end of the presentation. Is there any questions?
Thanks very much, Marius, for that excellent presentation and overview. While people are thinking about their questions, perhaps you'd like to put your camera on, Marius, and we'll just have a look and see. At the moment, we don't have any questions, but I have a couple of questions which might prompt sort of people to carry on from that. Your slide was very good about the silos, where you pictured everyone's working in a silo. And then you also mentioned that the contractor should get involved early on in that whole, design and build, because then you can probably come up with better solutions. Traditionally, of course, contracts, where you have the owner of the project that employs engineers who do the design and produce the drawings, and then it goes out to tender, and only then does the contractor even get a first look at it. How do you think in the future projects will go, particularly looking at it from the sort of contract point of view? Because then you'd have to get contractors involved almost when sort of like maybe sort of 40% of the design is done, to give their input, to construction things. What's your take on that?
So the contracting model is interesting, and maybe just one step back. So what I've mentioned, when a contractor should get involved a lot sooner, it's not to influence the design. It's not to dictate what needs to happen. Rather, employing contractors' knowledge during the design phase to explain that certain construction methods is easier, simpler, cheaper to do, and quicker to do. So you can optimize a lot sooner. A lot of the times that happens is, as a contractor, you submit your tender. If you're successful, you get awarded the work. You sign the contract. The next morning, you get a big stack of papers, drawings, and specifications, and immediately you are asked to absorb all of that information, hit the ground running within 2 to 3 weeks, and start with the construction work. That brings its own headaches, because the contractor needs to onboard their resources, understand the scope, understand the drawings, and then get started. If a contractor has the opportunity to get involved a bit sooner, they could have a better understanding of what they need to build. They can better coordinate themselves. So to come to your answer is, yes, there is the need, in my perspective, that contractors should get involved earlier. And the contracting model that's currently it's quite prevalent now is design and construct, where it's now the contractor that is in charge of the project and employs the consultants, subcontractors to try and get it done, or whether it's a joint venture or consortium. So there is a shift, but we only saw this now in larger scale projects. In the normal contracting model, it's still the engineer gets appointed, designs it, goes out to tender. At tender stage, it doesn't mean the design is finalized. Contractor gets awarded the work, receives the information, and also relies on still additional design information to come through the process. There is a pre-construction phase, and that's quite lacking in our industry at the moment, where pre-construction phase means, yes, the design is done, the contract is awarded to the contractor, but no physical work will happen up until a certain point in time where the design is progressed and the contractor is on board and understands the full scope and has resourced themselves correctly. So, yeah.
Okay, thanks very much for your view on that. So basically, we're saying with time, as the time evolves, that we do expect to see changes in the relationships between the employer, the design engineer, the contractor, etc., and the different phases, and basically to end up with better projects at the end of the day, and
Correct.
also possibly maybe some cost savings as well, as you mentioned, for the contractor can actually offer their professional advice and say, well, if you do it this way, it's actually better and easier for us, so therefore it would end up being cheaper. So I think that's an excellent insight. It looks, I can't see any more Q&A, so we've got a very quiet audience this afternoon, because normally they sort of come flooding in by now. So we'll give it another a few seconds and see if there are any more questions that people want to ask based on what Marius has presented this afternoon. So please put your questions in the Q&A, or even comment on there, or what you've seen this afternoon. Because obviously Marius has a lot of experience in this technology, and being on the contracting side gives us a very nice view, from the contractor's point of view. So that would be great. So do type your questions in. We'll give you another few minutes. We've got a message there from Kelsey. It says, thanks for the great presentation. Regarding cybersecurity, how is data encryption and data privacy vulnerability handled in these collaborative tools and emerging technologies? Maybe you can see the question there, Marius. Yeah.
Yes, no, I can see that.
Okay.
Right. Thanks, Kelsey. Yeah, so data privacy is a problem, even in our current way of operating, when information is shared. The benefit that we do have with the common data environment solutions. So let's, for argument's sake, use Autodesk Construction Cloud. They have a unique feature of keeping the data secured. Certain individuals will have permissions to view information, share information, or edit information. So with of course the vendors trying to sell their products, there is an added benefit that their applications conform to the ISO 19650 standards, and also ensure that data privacy is a top priority. The information can't just be shared to external parties without certain approvals.
Okay, I hope that answers your question, Kelsey. Yes, it is very important, as you say, Kelsey, is that, but it has to be controlled. There has to be like central controllers or project administrators that actually will decide who is able to see what. You can't just sort of dive in from the outside and have access to, information. If you take something like a nuclear power station or something like that, you wouldn't want everyone looking at the drawings. There's an example. So yes, there are, in these platforms that are available out there, you can in fact, have security in who can see what sort of thing. Okay, I don't see any more questions coming in, Marius.
I see there was one on the chat box there. I see.
Okay. Have a look in there.
Jerome has asked a question about what software do you recommend for 4D planning? All right, so this is the difficult one to answer, because it depends on what is your main goal you want to achieve. There are cheaper options on the market that you can do 4D planning, but it limits in terms of additional analysis, earned values, quantity takeoffs. But my preferred solution, and we've done some extensive research, would be Bentley Synchro 4D, as we found this one to not have any interoperability issues. So you can import multiple different 3D formats, 3D file formats, as well as planning applications like P6 or MS Projects. So that's something we prefer. Actually, the one at the back of my screen, that's actually an active project And that is just a screenshot of Synchro 4D. We see the Gantt chart at the bottom and the model at the back. And we found that Synchro 4D provides the best tool for this. But again, it's my opinion. I'm sure there's a few other options out there that people prefer, but that's it.
Okay, there's another one here from Mrs. H.J. Butters. Which form of contract would work best for a multidisciplinary contract? Does it have an impact?
Yeah, so there's a lot of questions about specifically BIM and what kind of contract that you use. Because UK is leading, one of the leading countries implementing BIM, and also have first-hand experience with difficulties with contracts. From what I could find, there's the NEC suite of contracts is better suited. It allows for additional annexures to be added on. We can bespokely update the main contract and include information from your BIM execution plan. But again, you need to do that analysis for every single project. Applying building information modeling is not a one size fit all. That's why you have a BIM execution plan. You have to decide what is the deliverables, what is you want to achieve on the project, and then you work according to that.
Okay, thanks, Marius, for that answer. We have a Christina who's saying rather has a comment rather than a question, which may sort of present this discussion regarding the use of AI such as ChatGPT. I have not seen anything sensible from a structural point of view out of this. Output looks reasonable on the surface, but often has errors. There is no control of information uploaded onto this platform. So the old adage, I guess, rubbish in, rubbish out, in my experience. What are others' thoughts on this?
So that's a very, very valid question. So with the advent of AI tools, we need to understand how they operate. So it's a predictive model. It tries to predict to give you an answer based on what you provide the model. So there's a term called prompt engineering, and that's something we need to really investigate. Prompt engineering gives almost a 400-word account of what you want out of the language model, ChatGPT. You need to be very specific about what you expect. You must set the tone. You must set the format that you want. And I know this can get a little bit laborious, but one other aspect you need to consider and look into is training. There's a specific term for it. It's the concept illusion. But in any case, you can train your own model. You can have inputs and desired outputs. So if you train your own ChatGPT model, you can use that as the basis for your questions. It will still be able to tap into other repositories, but you've given it a broader guideline. So let's, for argument's sake, for a structural engineer, there's certain terminologies and concepts that is valid for structural engineers, and certain questions need to be answered in a certain way that conforms to specifications and requirements. By setting up that specific model, you can get better answers out of ChatGPT. Because remember, ChatGPT taps into whatever has been loaded up to the internet. So you need to be very specific and very clear what you want out of it. And again, that's why we engineers, we need to use our discretion, see the information that's provided, and make a decision.
Yes, thank you very much for that answer, Marius. I think that's spot on. Yes, don't forget, that you are the engineer and you make the decisions. ChatGPT is possibly giving you ideas and won't always give you the right answer.
Correct.
Maybe over time, as 5 or 10 years time, when it's answered more and more questions, then the answers may possibly be refined because the sheer amount of data that it's got access to. But yeah, you have to be aware of that. So thank you for that question, Christina. One here from Jerome in the chat. You asked, will we be able to download the presentation? In fact, this has been recorded, so there will be a video that will be available on the SAICE IT channel. So yes, you'll be able to see the whole recording of the whole session. Thank you for asking that, Jerome. Clyde, how does a client specify BIM into a new infrastructure project if the client does not have previous BIM experience?
That is a
Interesting one.
very interesting question. So the industry, as well as clients, specifically clients, need to get understanding of what BIM is and what it's not. So in some of our conversations in the BIM community, a lot of people come to us and say, our client wants to BIM. We say, but what about BIM do they want to implement? No, they just want to BIM. So there needs to be an education process where the industry needs to understand what it is, what it isn't, and what it can deliver for us as an industry. Clients just blindly saying, yes, we want to implement BIM. You need to understand what you want, and that's where the BIM execution plan comes in. What are the deliverables? How do we operate? What do we want to get out of it? So that's a very, very interesting question.
Yeah, thank you for that answer, Marius. There's a comment there from an unknown user, basically saying they work in a BIM task team at Sanral. It's a starting point for us as an agency of the Department of Transport. In my brief time researching ISO 19650, BIM seems often to be very closely aligned to DTs, whereas BIM is a means of communicating, not software. Seems Marius is nailing it. Okay, so there you go, Marius.
I'm glad I'm not leading them astray, so that's good.
Yes, that's excellent. I'm just going to switch back to the Q&A just to see if we've got any more in there. I think there's a comment here from Johan. It's very interesting indeed, Marius, and especially the 3D model linked to timeline program. His comments that I was exposed to the 3D model during the construction of Medupi Power Station, and drones were used at certain GPS points and the data captured by a specialist team. The 3D model was quite helpful inside the boiler rooms where all the pipe and structural fittings could be visualized within the boardroom and discussion around progress and matters resolved. This works quite great in structural projects and will great to have this on a road construction project. So a bit of feedback from someone who's actually also started to integrate all the technology.
Excellent.
Moving down a bit more, Franciscus, how will the BIM be managed through contract stroke design stages? To resolve issues with backtracking, brackets recording design revisions made by the various parties involved on the design. So I think that might have something to do with like revisions.
Yes.
Possibly.
So
yeah, revision tracking.
Yeah. Yep. So that's where ISO 19650 steps in. It gives us a process on how to deal with revisioning and changes. There's different layers. So there is the published model, and then a layer behind it is the work in progress and the whole process to get it to a place to be published. The benefit of ISO 19650, as well as those CDE applications. So let's use Autodesk again as an example. All designing parties could actually publish their model to this common data environment that all parties involved, all the stakeholders, can see the changes as they progress. You can see revisioning comments and notes. You can verify the changes from the previous version to the current version and overlay the variations. So there are ways of properly tracking the revisions if you use a proper common data environment application.
Thanks, Marius. Thank you very much for that question. I don't see any new ones in the chat. I'm just going to go and check the Q&A just in case some have come in while we've been talking. No, I think we've answered all of them in there. So I think there's no more questions.
I think there's two more that came through. One from Hugo.
Is that in the chat?
Yes.
Oh, right. Okay. Yes, I've just seen them. One from Hugo, correct? Yep. So when it comes to asset management of road infrastructure, such as roads, bridges and culverts, etc., are there existing packages that are better suited for capturing and managing this type of data? I'm asking as Sanral is busy developing a BIM standard, but it is still at inception phase. Any inputs would be valued. Main aim for this will be for asset management.
Yes, excellent.
Yeah.
That's a very excellent question. So, yes, this is where we need to realize there's an ecosystem we're dealing with. So you can have your physical design, your 3D model, but then you get into the reality capture tools. So I previously spoke about an application for drones called Drone Deploy. Again, I'm not selling this product. I just know that this is one of the better solutions out there that interfaces drone photogrammetry as well as 360 photogrammetry. It also allows you to overlay your DWGs and your models onto the same data. So what it means is you have a proper drone survey of your site. You have the overlay of your drawings or your model, and then the 360 camera then stitches in. You can physically go take photos and link it to the location on the drone map. And through that, you can link documents, photos, notes, comments on that specific aspect. That's maybe one way to track it. I'm sure there's a few other solutions out there. There's a company called BMO that's also doing similar asset management aspects. I think that might be slightly better suited because that also provides extra external links to videos and procedures and documentation.
Yes, thank you for that answer. In fact, just going back to that and talking of roads and things like that, we did actually do a webinar probably almost a year ago now, where we actually did look at how we could look at asset management for roads. So maybe possibly want to have a look for that as well, Hugo. Okay, I'm just sort of looking through more in the chat.
So just to add on to that last question, there is another application you can consider. It's called Bentley ProjectWise. They have recently found that they've done a complete asset management of a harbor in Australia, where they also have the input from GIS data, design data, real world capture data, all connected. So again, it's always worthwhile just to see what's available in the industry.
Okay, thank you. Basically, we've just got just comments there. Christina's saying, doing research in structural engineering, we have projects that are utilizing BIM. That was at the UKZN. Okay, so that's good news. Okay, I'm just going to switch back to the Q&A to see what we've got there. I don't think there's anything new. No, I think that's it. So I think if there's no more questions coming in, I think we'll probably wrap up this afternoon's session. Well, I'd like to obviously thank Maurice very much for his excellent presentation that he's given us this afternoon, and obviously to acknowledge the time and the effort that is spent in preparing presentations such as this one. It's not 10 minutes work, so it's all in his own private time. So thank you very much, Maurice. We really appreciate that, your contribution to spreading the word on technology. So thank you. And the SAICE IT division really appreciates, coming to join us and use this platform to spread the knowledge to engineers. I'd also like to thank Debbie for managing the arrangements for organisation of this webinar. And for the attendees, lastly, if you would like to join the SAICE IT division and assist the committee, then please contact us, because now is the time, in fact, because we are putting together like our committee for next year. So please contact Debbie at SAICE. You can either contact her by email, or you could even contact, if you phone SAICE head office in Midrand and ask for Debbie Bestling, they will certainly be able to put you in touch with her. So you've got lots of ways of getting to Debbie. So with that, I'd like to wrap up this afternoon's session. So thank you all very much, all of you, for attending, giving up your time, and we hope that you have learned something, and also be able to spread the word. And as we say, keep on with your digital project delivery. This is the start of a long path, we feel. So now's the time to step on it and get going. So thank you very much, and have a good afternoon, the rest of it. And if you're driving back home, then drive carefully and drive safely. Thank you very much. Okay, bye-bye.